the lateral lines, those are called latitude because they're lateral. Okay, so we've got latitude, and longitude, and people get confused on that. Now I'm going to actually give you more information than you need, but hopefully it'll filter down into what you do need. Okay, if we have laterally going around the Earth, starting at the equator, then everything up here is a north latitude. Everything down here is the south latitude. Simple enough. Okay, and it goes from 0 degrees until you get up here. It's 90 degrees. Okay, so 0 degrees to 90 degrees, and then you get up here to the North Pole. So if you're going down to the south, it's the same 0 degrees to 90 degrees, except it's the southern hemisphere. Okay, all right, so figure that out. Now, it's in degrees, right? So many degrees. The lateral lines never touch. They just go round and round and round, but they never touch. But you get 90 degrees, then you can have 1 degree of latitude. So you can have 90, you can sure as hell have 1, right? Now, on 1 degree, we can divide that up into 60 minutes. Okay? So 1 degree can be divided up into 60 minutes. Now, we could divide that up into seconds, and I'm sure in some machine they do. Okay? But all we divide them up into is half. So we divide it up into 30 seconds, which equals a half a degree. Okay, so it's just simply a way of dividing it up. That's all. It just divides it up. So we start with 0 on the equator, and if we're going north, we call it north. If it's going south, we call it south. But these latitude lines, there's 90 altogether. So where do we work right here? If you look on there, like, is that San Francisco?
Yeah.
Okay, if you look over there, it's going to tell you the latitude line for San Francisco, and I want to say somewhere like 38 or something. 37. Okay, 37 degrees and 30 minutes. Okay, and then 38 degrees. And 38 degrees, 30 minutes, 39 degrees, we're in Sacramento. Does that make sense? Okay, so if you go over here and you look at Sacramento, it doesn't have to be exact because we're not doing exact stuff. 39, 30, and there's 40. So 40 degrees is right up here. Hey, there it is. 40 degrees is right up here. 38 and a half, about 39, we're down in Sacramento. Okay? So that's a latitude line. And so 39 and 30 seconds, or 30 minutes. So otherwise 39 and a half, you're close.
To
Sacramento, or 38 and a half. Actually, it's closer to 38. 38 and a half, that's pretty much where we are. Now, if you were figuring out something on a GPS to get really close, look what you got here. You got these little lines dividing it up even more so, okay? Into minutes and then seconds. Okay? all right, that's all we're saying. Okay, now
So that would be 38 degrees, 30 minutes for
Yeah,
Sacramento.
Yeah. And when you punch in, okay, when you have your GPS and you say, if we only knew how to do it on your unit,
Right.
we're flying over that house and we go, that's where we want to mark, and we push it and say, Bink, and then it says name it, and it's Carl's house, okay? It gives you these latitude and longitude, and it's a long string of numbers. That's what they're giving you. So if you kind of know that, it starts to make more sense.
Yeah.
Okay? All right. So this is what you got to remember. Latitude laterally is going around the equator. Latitude's going around it, okay? And then we're coming up for it because we're not flying to Australia. We're not going below the equator. So the numbers are coming up, and how high can they go? 90, and then they run out. Okay? All right, and these lines never meet, do they?
No.
Okay, all right. So we pretty well beat that to death. And they use as a reference the equator. That's the reference. Now, we got to go north and south. That vertical line, that's longitudinal. Longitude. Longitude, the lines do meet because where do the lines meet up? They meet up at the geographic true north and geographic true south. Okay? And those lines go all the way around the circle. Well, if they go all the way around, how many possible degrees could you have?
360.
360. So it's 360 degrees. Now we can also go 60 degree or 28 degrees and a half, right? So we can go minutes on that as well. Okay, so we can get 360 degrees, but we can divide them into half a degree, which is 30 minutes. Again, so that didn't change.
Does it work the same way with the half seconds?
Yeah.
As a half a degree?
You could divide it down to a point where it could tell you what seat you're sitting in.
Yeah.
But GPSs aren't quite that accurate. What is a GPS accurate to? I think it's down to like a meter or so.
Yeah,
Well,
3 feet.
Yeah, about 3
Right.
feet.
yeah, I mean, I know that even on here, if I'm sitting in my house, I can see, if I zoom way in, it shows me where I'm at in the
Where you're
house.
at.
Yeah.
But
I'm in the
it'll-
living room,
it-
right?
Right.
You know,
If you're
which I
putting-
hate.
If you're putting a bomb through a window, 3 feet's close enough.
Yeah.
You know,
Yeah.
and so, but it will get you to that airport. It'll get you to the end of the runway, close to the center line. It'll get you there. So it can be a little bit off. I think someday it'll probably be inaccurate where you could tell your neighbor you built your fence on my property line. You're over your property line. But right now it's not. It's like 3 feet.
So, like, if you're looking at the chart here,
Yeah.
and let's just say we go dead in between 38 and 39 degrees, we're going to be at 38.
And a half.
But we could call it out as 38 degrees, 30 minutes.
Yes.
Okay, now the next.
Then you could go 38 degrees, 29 minutes, 28 minutes, 27
Right,
minutes.
and then so to further break it down from there,
You'd go to
we'd
seconds.
go to seconds. So you
And
can.
the seconds would be 60.
And which one of these lines represent that?
None. They don't show you.
They don't show that.
They don't show you
So
seconds.
these are only minute lines.
Those are only minutes. Yeah. Because flying an aircraft, you don't need to be that accurate down to the. But you would if you were using it for real estate, I guess, but not for flying.
Right.
Okay. But the problem, we see where the equator is. That's not a problem. But we got a problem of where do we start? Well, we start where we always start, and that says who invented the system. That's where we start. So what, and I've been there, I took the little boat up the Thames River,
Greenwich, England, isn't it?
Greenwich, England, and I said, I want to go to the observatory at Greenwich, England and see the fancy floor markings, you know, where this is where things begin. And that's pretty cool if you're into that sort of thing. Was not impressing who I was with. Like,
No.
yeah, can we go now?
Right.
Yeah. Where's the gift shop? And so Greenwich, England is 0. That's where it's 360 all the way around.
And it starts at 1, 2, going
Yeah.
west.
Now,
right?
let's pretend that's Greenwich, England, to be up here.
Okay.
Okay. By the way, gee whiz point of the day. Most things when they come up with what is the stuff we want to, it's figured to be at about 40 degrees north latitude. That's kind of Sacramento. It's damn close, or Redding. It's Redding. About 40 degrees north latitude is when they went all the way around the world. That's where they measured things from. About Redding around the world. Okay? So anyway, getting back to Greenwich, England, that was 0. So everything to the east of that, okay, is east, and everything to the west of that is west, and then you go out. So if you go east this way and west that way, and you have a total of 360 degrees, if you're dealing with east or west, what's the longest you can go? 180. Okay, so it's 0 to 180 east, or 0 to 180 west. That makes sense? That's as high as you can go. Because if you go further than that, you're coming back.
What's the reciprocal on the other side? Is it in the middle of the ocean or something?
You know, I
180?
don't think I've ever looked. I have to get a globe and take a look at China. I don't know exactly. But I do know this, because it was a personal thing. We flew from South Carolina back to Travis to Hawaii to Philippines, Guam, Philippines, Diego Garcia. And when we got to Diego Garcia, it's a little island off the coast of Africa, we're coming back. So it ruined any debate for me on flat Earth, because it's coming
Up
back.
until that point, did you believe the Earth was flat?
Of course, there
Yeah.
was a giant ice shield
Yeah.
there, and that's what kept the water from running off the side of the Earth. So that disproved that theory, right? The Earth is going to be a pizza with a crust around it, right? And they say, what's the crust made out of? And somebody said, ice. You know, the Flat Earth Society is a real thing.
Yes.
I mean, there are people that believe that. They also believe the Earth is 6,000 years old. So, yeah.
Yep.
The Earth is square.
Yeah, the Earth is square. Okay, so the what happens to the longitude lines as they get closer to the North Pole or the South Pole is they get closer together, because they meet at the geographical true north or geographical true south. Okay, so if you're standing on the geographic true north, which way is south? Every direction is south. And if you're standing at the true south, every direction is north. So a compass isn't going to do you any good. Right? Okay. So, you know, I find that if somebody would have explained that to me in private pilot ground school, I wouldn't have had so much trouble with, what's this latitude and longitude crap they keep talking about? Okay? Does that make sense a little bit? You know, to do it that way.
However, if you were on the geographic true north, a compass would still work because
Whatever,
It's magnetic.
it's going straight down.
Go down, yeah.
The compass is going straight down. And no matter what you did, it would just read. It's every direction.
yeah, but it would magnetic north isn't at geographic north, right?
No, it's a little bit off, but it's
About how far off is it?
It varies every minute of the day. It varies because, okay, I'm going to throw out a number that I could be wrong, but I think this is the number. It's moving about 10 feet a day. Now, I'm not going to guarantee that is right, okay? But I've read articles where they say it's moving at about 10 feet.
That's a lot.
Yeah, it's a lot up there, yeah. Yeah.
No, then it goes back. I mean,
And it goes back.
sideways.
It will go,
Sideways,
it
yeah.
wobbles all over the place. And someday it will totally reverse. And there's some places on Earth that it's already switched 180. And it's down near the Antarctic. There's spots out in the ocean where north is south and south is north. And so you don't use a compass there because it won't do you anything.
But it won't affect GPS.
And as it's about to switch, it gets weaker. It gets weaker during the switch and then does it. Not going to be in our lifetimes, but yeah. And the reason, and it's flip-flopped any number of times. And the reason they know that is they break open rocks and they get the little north-south on the rock and they can see where it switches.
It during lava flows.
Yeah.
During when lava is flowing, the magnetic particles are sensitive to where the magnets are.
Yeah.
So they look at the orientation when the rocks solidified again. They can look at the orientation based on where the rocks were found and determine what magnetic north was at the time.
At that
Flowing,
time, yeah. And it's enough where eventually runway 16 out here will be designated runway 15. It does change in your lifetime, but that's about it. That's about it. Okay. And supposedly it's speeding up and blah blah blah. Okay, so but this okay.
We only got 12 more years to worry about it anyway.
Yeah, that's right. The world ends. Okay. So, but
Again?
but what they do, so what does the FAA really want you to know? And I think it's important to kind of get a grasp on this because of GPS. I think the GPS figuring in those numbers. And when I used to program in an INS, that's what I programmed in was an INS on military. And and you had to know where you were. And they would say, if you're in this spot, you're in this latitude and longitude.
You better move. We got income.
Well, you would program that in because you wanted it to tell you where to go, and it couldn't tell you where to go unless it knew where it was. Because it's like a box with no windows. Okay, but GPS is totally different. Because the INS is totally independent. You don't need anything but the INS. And it senses movement. How it does that? Hell if I know. It's above my pay grade. But GPS, it does know where you're. It tells you where it's at. Okay, so I just thought it was a good idea to go over that. If that makes sense? Okay. So now here's the thing about navigation.